This is The Hidden Life of Trees by Peter Wolben. We're in chapter 27, Street Kids. Have you ever wondered why giant redwoods in Europe never grow particularly tall? Even though quite a lot of them are more than 150 years old, very few have yet topped 160 feet. In their homeland, forests on the western slopes of the Sierra Nevada mountains in California, they easily grow more than twice that size. Why don't they do that in Europe? If we think back to tree kindergarten, to their extremely long and drawn-out youth, we might be tempted to say, they're still children. What do you expect? But that doesn't jibe with the enormous diameters of the older giant redwoods in Europe, which often exceed 8 feet. Clearly, they know how to grow. They just seem to be putting their energy into growing in the wrong direction. Their location gives a clue as to why this might be the case. They were often planted in city parks by princes and politicians as exotic trophies. What is missing here, above all, is the forest, or more specifically, relatives. At 150 years old, they are, when you consider a potential lifespan of many thousands of years, indeed, only children. Growing up here in Europe, far from their home, and without their parents. No uncles, no aunts, no cheerful nursery school. No, they have lived their lives out on a lonely limb. And what about the many other trees in the park? Don't they form something like a forest? And couldn't they act like surrogate parents? They usually would have been planted at the same time, and so could offer the little redwoods no assistance or protection. In addition, they are very, very different kinds of trees. To let lindens, oaks, or beeches bring up a redwood would be like leaving human children in the care of mice, kangaroos, or humpback whales. It just doesn't work. And the little Americans have had to fend for themselves. No mother to nurse them or keep a strict eye out to make sure the little ones didn't grow too quickly. No cozy, calm, moist forest around them. Nothing but solitude. And if that weren't enough, in most cases, the soil is a complete disaster. Whereas the old growth forests offer soft, crumbly, humus-rich, and constantly moist soil for their delicate roots. European parks offer hard surfaces that have been depleted of nutrients and compacted after years of urbanization. What's more, members of the public like to walk up to the trees, touch their bark, and relax in the shadow of their crowns. Over the decades, constant trampling around the base of the trees leads to further soil compaction, which means that rain drains away far too quickly, and in winter, the trees cannot build up a supply of water to last the summer. The mechanics of planting also haunt the trees for the rest of their lives. They are kept alive and handled in nurseries for years before being moved to their final locations. Every fall, their roots are trimmed to keep them compact in the nursery beds so that they can later be moved more easily. The root ball, which for a 10-foot tall tree grows to about 20 feet in diameter if left to its own devices, is cut back to about 20 inches. And to make sure the crown doesn't wilt from thirst, thanks to the root reduction, it too is heavily reduced. All this is done not to improve the health of the tree, but simply to make it easier to handle. Unfortunately, when the roots are pruned, the brain-like structures are cut off along with the sensitive tips. Ouch! After that, it is as if this interference makes the trees lose their sense of direction underground. They stop growing roots down into the soil and form a flat plate of roots near the surface instead, severely restricting the tree's ability to find water and food. At first, the young trees don't seem to mind. They stuff themselves with sugary treats because they can photosynthesize as much as they like in full sun. It's so easy to get over the loss of a mother's tender care. And in the early years, the water problems in a rock-hard soil are barely noticeable. After all, the saplings are being lovingly cared for and watered by gardeners when they get dry. But above all, there is no strict discipline. No, take it easy. No, just wait a couple of 100 years. No punishing light deprivation if you don't grow up really straight. Every young tree can do just as it likes. So, every year, they go at it as though they were in a race. And every year, they put on a growth spurt. After a certain height, the childhood bonus seems to run out. Irrigating 65-foot-tall trees takes an enormous amount of water and time. To thoroughly moisten the roots, the gardeners must spray many gallons of water out of their hoses per tree. And so, one day, the care simply stops. At first, the giant redwoods don't really notice. They've lived high on the hog for decades and done whatever they wanted. Their thick trunks are like pouches, attesting to an orgy of solar indulgence. In the early years, it doesn't really matter much that the cells inside their trunks are very large, contain a lot of air, and therefore are susceptible to fungal infections. Their side branches also show signs of their loutish behavior. The trees in the park know nothing about the etiquette manual that guides the old growth forests calling for thin branches in the lower ridges of the trunk, or even for no branches at all. Thanks to the generous amounts of light that reach right to the ground, the redwoods grow thick side branches that later increase their girth, so much that the image the trees bring to mind is that of doped up bodybuilders. True, all the branches on the lower 6 to 10 feet of the trees are usually sawn off by the gardeners to give visitors an unobstructed view of the park. But when compared with old growth forest, where thicker branches are not allowed below 65, and sometimes not even below 165 feet, the tree's growth is brazenly decadent. What the trees end up with are short, thick trunks, topped with crowns. Extreme examples of park trees seem to be nothing but crown. Their roots don't penetrate more than 20 inches down into the heavily trampled soil, and therefore they offer little in the way of support. That's very risky, and trees of a normal height would be much too wobbly. The growth habit of redwoods in the far-off old growth forest ensures a low center of gravity, so they are pretty stable. It takes a huge storm to upset their equilibrium. Once European redwoods have passed the 100-year mark, the trees are now the age of school children. That's the end of easy living. The topmost branches wither away, and no matter how hard the trees try to grow up again, they have reached the end of the road. Their wood is impregnated with natural fungicides, so they can hold out for many more decades despite injuries to their bark. It's quite different with other species of tree. Beeches, for example, react badly when thick branches are sawn off. Take a closer look the next time you take a walk in a park. you'll find hardly any large deciduous trees that don't show signs of having branches trimmed, sawn off, or interfered with in some way. This pruning, it's actually more like a massacre. It's often only for aesthetics, which dictates that the crowns of trees lining a walk or driveway are all the same size and shape. A severely pruned crown is a severe blow for the roots, which grow to a size optimally suited to serve the above ground parts of the tree. If a large percentage of the branches is removed and the level of photosynthesis drops, then just as large a percentage of the underground part of the tree starves. Fungi now penetrate the dead ends where branches have been removed and the trunk has been sawn off. The wood is filled with air pockets thanks to the tree's quick growth as a youngster, and fungi have a field day. After only a few decades, which is incredibly fast for a tree, this inner rot can also be seen on the outside of the tree. Complete sections of the crown die off until the local authorities cut the crown off completely so that it no longer poses a safety hazard for visitors, leaving huge wounds where the tree has been topped. The waxy substance painted over the damaged trunk, supposedly to protect it, often hastens the tree's demise because it traps moisture inside, creating the damp conditions fungi love. In the end, all that remains is an empty shell that cannot be saved, and one day will be chopped down. And because there are no family members who can rush to help these urban trees, the stump will die quickly and completely. A little while later, a new tree will be planted and the drama will begin all over again. Urban trees are the street kids of the forest, and some are growing in locations that make the name an even better fit, right on the street. The first few decades of their lives are similar to those of their colleagues in the park. They are pampered and primped. Sometimes they even have their own personal irrigation lines and customized watering schedules. When their roots want to go out and get established in their new territory, they're in for a big surprise. The soil under the tree or pedestrian walkway is harder even than the soil in parks because it has been compacted by machines using large vibrating metal plates. That's a huge disappointment for the tree. The roots of the forest don't actually grow very deep. Few species grow deeper than 5 feet, and most call a halt to downward growth much sooner. That's not a problem in the forest, where there is almost no limit as to how wide the roots can grow. Unfortunately, this isn't the case on the side of the street. The roadway restricts growth in one direction. There are pipes under the pedestrian zone, and soil has been compacted during construction. When trees are planted in these restricted spaces, conflicts are inevitable. In such places, plane trees, maples, and lindens like to feel out underground wastewater pipes. We notice the damage when the next storm comes and the streets fill with water. Then specialists armed with root probes investigate to see which tree has caused the blockage. The culprit is sentenced to death for its excursion under the sidewalk and into what it thought was paradise. The offending tree is cut down, and its successor is planted in a built-in root cage to discourage such behavior in the future. Why do trees grow into pipes in the first place? For a long time, city engineers thought the roots were somehow attracted by moisture seeping from loose connections between the pipes or by nutrients in the wastewater. However, the results of an extensive applied study by the Rural University Bochum point in a completely different direction. The study found the roots in the pipes were growing above the water table and did not seem interested in extra nutrients. What was attracting them was loose soil that had not been fully compacted after construction. Here, the roots found room to breathe and grow. It was only incidentally that they penetrated the seals between individual sections of pipe and eventually ran riot inside them. What this means is that when trees in urban areas run up against ground as hard as concrete, wherever they turn, they get desperate, and it is only an absolutely last resort that they finally find a way out into sloppily backfilled trenches. Once they get there, they are a problem. There is no remedial support for the trees, only for the pipes, which are now reburied in especially well tamped down soil, so that the tree roots can no longer find a footing there. Are you surprised that summer storms topple a particularly large number of street trees? Their puny underground anchoring systems, which in nature could cover more than 700 square yards, and are now restricted to an area shrunk to a tiny percentage of that, are not capable of supporting trunks that weigh many tons. But there is even more these tough plants have to bear. The urban microclimate is heavily influenced by heat-inducing asphalt and concrete, whereas forests cool themselves on hot summer nights. Streets and buildings radiate the heat they soaked up during the day, keeping temperatures elevated. Radiated heat makes the air extremely dry. Not only that, but it's full of exhaust fumes. Many of the companions that look after trees' well-being in the forest, such as the microorganisms that make humus, are missing. Mycorrhizal fungi that help collect water and food are present only in low numbers. Urban trees, therefore, have to go it alone under the harshest conditions. As if that were not enough, they also have to deal with unsolicited extra fertilizers. Above all, from dogs, which lift their legs at every available trunk. Their urine can burn bark and kill roots. Winter salt leads to similar damage. Depending on the severity of the cold, salt is sometimes applied around trees at the rate of 2.2 pounds per square yard. In addition, the needles of conifers, which are still attached to the branches in winter, have to deal with the salt spray thrown up by the car tires. At least 10% of the salt ends up in the air and falls back down on trees, among other resting places, where it burns the foliage. These painful injuries show up as small yellow and brown spots on the needles. The burns reduce the tree's ability to photosynthesize the next summer, and therefore weaken the trees. Weakness equals pests. It's easier for scales and aphids to strike because street trees have limited resources they can put toward defending themselves. High urban temperatures are a contributing factor. Hot summers and warm winters favor the insects, which survive in large numbers. In Central Europe, one species constantly makes headlines because it is a menace to the human population as well. The oak Precessionary. This moth gets its name because after feeding in the crown, its caterpillars crawl nose to tail down the trunk in long lines. They protect themselves from predators using thick webs, where they retreat to molt as they grow. People fear the little pests because they are covered in fine stinging hairs, which break off when you touch them and make their way under the skin. There, like stinging nettles, they release substances that itch and cause welts and can even trigger acute allergic reactions. The stinging hairs on the shed skins remain hanging in the webs and can inflict damage for up to 10 years. In urban areas, the arrival of these insects can spoil a whole summer, yet ultimately, they are not the ones at fault. The oak Precessionary is relatively rare in nature. Just a few decades ago, it was on the list for critically endangered species, and now everyone everywhere wants to get rid of them. Population explosions have been described for more than 200 years. The German Federal Agency for Nature Conservation doesn't attribute these infestations to climate change and rising temperatures, but to the presence of attractive food sources for the moth. They love warm crowns drenched in sunlight. In the middle of the forest, these are hard to find. The few oaks that grow in the forest are mixed in with beeches, and only their topmost tips reach the light. In the city, however, oaks stand out in the open, where they are warmed by the sun all day long. The caterpillars love this, and as the whole forest in urban areas offers such perfect conditions, it's no surprise that there are population explosions, which are a stern reminder that oaks and other species growing along the streets and between houses have to fight for their lives. At the end of the day, the stresses the trees must bear are so great that most of them die prematurely, even though they can do whatever they want when they're young. This freedom is not enough to compensate for the disadvantages they face later in life. One consolation is that because streets and pathways are often planted with rows of the same species of trees, at least they are able to communicate with other members of their species. Plane trees, recognizable by their attractive bark, which peels off in colorful flakes, are a popular choice for these regimented plantings. Whatever it is these street kids talk to each other about through their scent mail, and whether the tone of these messages is as rough as their lives, the street gangs are keeping this information strictly to themselves. That's the end of chapter 27. Next time we'll be in chapter 28. Burnout.